Mark your own, here we go. It's been a while since we've seen good old Dan. It said write each solution as a fraction unless otherwise indicated, 1 mark each. And bag contains some marbles. Determine the probabilities of the following if how many marbles are selected? 2. Tree. So my tree is going to look, you know what? I'm going to do it off in the margin here. My tree is going to look something like this. On the first pick, I can have red, green, or white. You know what? I'll call it red on the first, green on the first, white on the first. Can make it, Jordan? How many reds are there initially?
10.
Out of?
21.
How many greens? 6 out of 21. How many whites? 5 out of 21. Double check, they add to 1. Woohoo! Now, all number 1 asks is what's the or 1A, what's the probability that the first one drawn is white? This is saying the probability that you get a white on the first. Why, that is 5 out of 21. B, the second one drawn is white, given that the first one drawn is white. Now, what it's really asking for is this. That's how we would write that. I don't need to fill in the rest because this seems to be all they're interested in. It said given the first one was white, so we picked a white. How many whites are now left in the deck? Sorry, in the bag? 4 out of? Mr. Dueck, wait a minute. Maybe I thought you said and means multiply. This question did not say 2 whites in a row. This question said, okay, what are the odds of getting a second white once you've already gotten a white? So it's actually asking for that. If you told me the answer was 20 out of, subtract the 3, 420, whatever that reduces to, I'll give you a half mark. But that's not what this question asked. This question, and I phrased it very, very carefully, Darian, said, what's the probability that the second one is white? Oh, but I need to tell you what happened first in order to figure that out. Is that okay? But hopefully number 2 was a little easier. What's the probability of not A? 0.82 or 82%, is that right? 1 minus the complement. Hopefully you're cluing in now why the complement can be such a nice shortcut. The summary of a recent survey is shown below. Now, what did I say as a hint? Use a what? What if I hadn't said that? Is it percentages? Are there 2 separate categories? Did they tell me both or neither? That's a Venn diagram approach is the best. That's my checklist. Is that okay, Jordan? So I'm going to do a Venn diagram. I'm going to do my Venn diagram over here. Looks like I have hamburgers. I have pizza. Jordan, where do I always start in a Venn diagram? In the middle. Either they gave it to me or I'll put an X there. Did they give me the both or am I putting an X there? So I'm going to go 0.4, or you could leave it as 40%, but I usually change it to a decimal. So what's going to go in the H category? Not that, because now I already have 100%. What's going to go here? 20% or 0.2. There's my 60. What's going to go in the pizza category? 0.3. By the way, what's going to go in the neither category? Or 10%, because it's got to add, because it's a percentage, I know what it has to add to. So your answer is 10% or 0.1. I didn't say, well, and actually I said what percentage like neither, so I guess that implies do this as a percentage. Is that okay? By the way, I like all of these questions. I'm going to use this in all your quizzes to make up your tests, although I'll have to convert a few of them to multiple choice as well. Number 4 was the tough question, the first really nasty. Number 4 says, a game begins with 2 cards being dealt from a randomly shuffled deck of cards. Here's my deck. To win, once I pick 2 cards, the third card has to be between them or equal to them. So it just told me that we picked, I was hoping I might have it here, a 3 and a 10. Let me find from my deck of cards a 3 and a 10. Oh, you know what? Let's just draw a picture. So I picked a 3 and a 10. By the way, why am I not using a tree here? How many cards am I picking once I've picked the 2? Only 1. Okay, so I'm going to solve this by counting. First of all, what cards are between 3 and 10? Or, 8, how many 4s are there in the deck grand total?
4.
How many 5s? How many 6s? How many 7s? How many 8s? How many 9s? So how many winning cards are there remaining from that group? 4 times 6. I can win in 24 ways, but it also said, Brianna, I could win if it was equal to the 2 cards that I picked. I picked a 3. How many 3s are left in the deck? How many 10s? How many winning cards are there in the deck grand total? 30 out of how many cards are left in the deck? Careful, don't say 52. That's the answer. This, Brendan, goes back to me saying in the very first lesson, if you can count it for one thing, you can solve it. Now, if there's 2 events, yeah, and means multiply and or means add minus the other. This is just one event. You're picking 1 card. Count it. Count it. Turn the page. Each of the 11 letters of the word mathematics is placed on a separate card. A card is drawn and not replaced. A second card is drawn. What's the probability that they're both vowels? Okay, and it said hint, use a tree. How many cards are we drawing?
2.
That's how I know to use a tree. So it seems to me my tree is going to look like this. Vowel on the first, not vowel on the first. How many vowels are there in the deck? 1, 2, 3, 4. You know what? I cleverly put a dot above each one to make it easier to count. 4 out of?
11.
By the way, how many non-vowels are there in the deck?
7.
Then, vowel on the second, not vowel on the second, vowel on the second, not vowel on the second. What's the event that we're interested in here?
But they're both vowels.
Okay, that's going to be that one. So you know what? I'm not going to bother filling in the rest. Down this branch, we got a vowel. How many are left in the deck?
3.
Out of?
10.
3 out of 10. So, the probability of vowel 1 and vowel 2 is 4 out of 11, and 3 out of 10 is 12 out of 110. Or if you went to lowest terms, 6 out of 55. By the way, what if I had said only 1 vowel? Well, that would be this branch, or that branch. I would have to fill in the rest of the tree, and it would be multiply down, add across. What if I said no vowels? That would be that branch. I have to fill in the rest of the tree. So all of those, to me, Sterling, would be fair game. Got the quiz out?
No, I wasn't here.
Okay, could you have mentioned that sooner than this? Please? I thought I asked if any. Okay, number 6. Number 6, Taylor, can you read me the first word of number 6, please?
1.
How many cards? I'm not doing a tree, I'm going to count. I may use the formula because it may be or minus the over. You know what, though? I think I can just actually, like, count. So we have event A getting a heart, B getting a face card, event C getting a 10. Probability of A, okay, I've done this a few times, Mr. Dueck. This is 13 out of 52, or 1/4. I'm not going to go across. I notice it goes down. A, B is below it, and I'm going to assume it makes more sense to follow that way. So B, how many face cards are there in the deck? 12 out of 52. Or, in lowest terms? 3 out of 13? Is that what it ends up being? Okay. 1 mark each. Getting a 10. How many 10s are there in the deck? 4 out of 52, or 1 out of 13. Not B, 40 out of 52, or 10 out of 13. I didn't count, I used the complement. All right. A or B, which means one or the other minus the overlap. What's the probability of A? 13 out of 52 plus. What's the probability of B? 12 out of 52 minus. How many hearts are also face cards at the same time? 3. By the way, are you seeing why I don't like reducing the fractions? Because if you gave me 1/4 plus 3 over 13 minus 1 out of 30, I would much, this is going to be 13 plus 2 in my head, no calculator required, Ben. What's 13 plus 12? I said 13 plus 2. 13 plus 12 is 25. Take away 3 is, it's going to be 22 out of 52, which is 11 out of 26, I think. A and C. Mr. Dueck, and I know and means multiply, but wait a minute. How many cards are we picking here? I'm going to count it. How many cards are hearts and 10s at the same time? In fact, what do we call that card? The 10 of hearts. And there's one of them. That was too easy, I think. Okay, G and H are tougher. It says A or not B. Okay, I'm going to say that's going to be A plus not B minus any overlap. A, 13 out of 52 plus not B. Hey, I have that over there. 40 out of 52 minus how many cards are hearts and not face cards? Dom, no one else answer. How many cards are hearts and not face cards? How did you figure that out? Did you actually count them? Or did you say there's 13 cards that are hearts? How many of them are face cards? And you use the complement? Excellent. Then I give you a compliment. Huh? Eh? Huh? No? Okay. Tough audience. Oh, and these are a lovely common denominator. I don't add the bottoms. It's going to be out of 52. And it's going to be 13 plus 40, 53 minus 10, 43, is that right? Mm-hmm. And I don't think that'll reduce. I think 43 is prime. H, not A and not B. Again, I'm going to count. So what this is saying in English is how many cards aren't hearts and at the same time are not face cards. How many cards at the same time aren't hearts and are not face cards? You know what? Oh, that's too far. I got a deck of cards here. Right there. I think I'm going to figure it out by using my magic marker. Here's the hearts. Here's the face cards. How many aren't either of those at the same in other words, how many don't have any coloring on them? Now I see 30. And now I think I can actually say, oh, you know what? There's 52 cards. I can't use the face cards. That leaves me 40 left. Oh, and there's still 10 left that are hearts. That's a picture of not hearts and not face cards at the same time. But now I'm going to erase that picture because I don't want to gum up the notes. How many did you say there were? Out of? That's it. If you can count it, you can solve it for one event. Which is in lowest terms. Did anybody go to lowest terms? 15 out of 26? Oh, just divide by 2, divide by 2. I could have done that in my head. And now I turn the page. I like number 6, I like number 6, I like number 6.
Number 6 on the test.
It's nice to do dice questions because all of you have grown up playing board games. But often, because a normal dice is 6 by 6, and that's a lot of work to draw, I'll use a four-sided dice, a tetrahedral dice. How many dice in this question? 2. How many options for each die? I could do, don't write this down, I could go, that gets a little unwieldy. And especially if it was a 6 by 6 dice, I'd have 6 branches, and then each of those would have 6, 6, 6. I'd have 30. You know what? I'm going to do a chart. We did one like this. I'm going to go, here's the first die, and it can be a 1, 2, 3, or 4. And here's the second die, and it can be a 1, 2, 3, or 4. That's why I said draw the sample space below. So the sample space, you can get a 1 and a 1, a 1 and a 2, a 1 and a 3, and a 1 and a 4. 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4. It takes me very little time to quickly draw this. And each of these are equally likely because they're dice. By the way, how many outcomes are there? 16. Each fraction is going to be out of 16. Okay. The sum is equal to 6. See it? And the nice thing about a chart is usually you'll find whatever event they give you is some kind of pattern like diagonals or something like that. Clearly going to be. The product is a multiple of 3. I think. Nothing else works, right? 3 goes into the product. The product is a multiple of 3. Product means multiply. Did you say 7? The number showing up on the first die is bigger than the number showing up on the second die. Okay, where's the first die? For me, I did my, oh boy, you know what? Look up. I'm going to call this the first and this the second because apparently I wrote the second one first like an idiot. Anyways, doesn't really matter. You're going to get the same answer no matter what. The first number is bigger than the second number. I think it's this whole bottom corner, isn't it? It's going to be some kind of a pattern like that. Everything in that bottom corner, which is 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, yep. 6 out of 16, or 3 out of 8. The sum of the 2 dice is equal to 6, or the product of the 2 dice is a multiple of 3. Or means add minus the overlap, but I think I'm just going to count. 1, 2, 3, 4, 5, 6, 7, 8. Is it 9 out of 16? Mm-hmm. So that's one way to get there. Or you could say it's going to be 3 plus 7 minus, oh, there's one that's circled twice. Turn the page. You guys didn't have a part E, did you? You didn't have one more question here, did you? No?
No.
Okay. I used to, but I nuked it. Oh, hey, we're back to counting. A, 6 out of 15, or 2 out of 5. B, 5 out of 15. Not A, 9 out of 15. Not B, 10 out of 15. Yes? I haven't made any dumb mistakes. A and B, 2 out of 15. A or B. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, you could also get it by going 6 plus 5 minus the overlap. Not A and B. Well, A and B is 2, so not would be 13. Not A or B. Oh, you know what? That's these guys. That's neither. 1, 2, 3, 4, 5, 6. One mark for each of those. Justin loves ballet. Do I have a Justin in this class? I forgot to change the name. Usually, you know what? I was going to make it Brendan, I think, and I forgot. Oh, well. Decides to enter 2 ballet contests. He feels that he has a 65% chance of winning the first contest and a 20% chance of winning the second contest and only a 19% chance of winning neither. Now, it says using a Venn diagram, but I was already leaning towards that because there was 2 contests and they gave me neither and percentages. So let's draw my Venn. There's contest 1. There's contest 2. Jordan, where do I always start with a Venn diagram? Did they give me both? Read carefully. Did they tell me both? Oh, I like number 8, I like number 8, I like number 8.
Number 8 on the test?
Yep. Why in particular? Because Mark, I have to put an X there. I don't know both. Mark, what's the probability that Justin wins the first contest? Am I going to put a 65% right here? You're going to say no. What am I going to write there instead? Yes. And what am I going to put in the circle number 2 there? Minus X. And what am I going to put outside the circles? They did tell me neither. Great. Okay? So how's that help? Because I know what these 4 groups have to add to. It's a percentage. What do they have to add to?
100.
So as an equation, 65 take away X plus 20 take away X plus 19. If I add up all 4 groups, has to add to 100. You're going to find when you do this, Brendan, one of your X's and always cancels one other one. You'll still have a little negative X kicking around. 65 plus 20 plus 19. I get 104. 104 take away X equals 100. I think I can solve it in my head. 104 take away what equals 100? I think X has got to be, Kyle, 4, yes? So now I'm going to go back to my diagram and I'm going to say 4, 61, 16. And now I can answer everything. Both contests. Right? Only the first but not the second. Only the second but not the first. At least one. Although I went 100 minus 19 to get that. 1 mark for each of those. Can you give yourself a loverly score on this wonderful take-home quiz that summarizes almost everything we've done so far? out of 30, please. Problems involving conditional probability. This is where stuff gets counterintuitive. Chelsea, this is where it gets so counterintuitive that, in all honesty, I fall back on the formula. I set up a tree, but I use the formula to deal with the tree. What we're going to ask is this. Instead of going down the tree, how do we go backwards up the tree? What are the rules for that? If instead of saying, tell me what happened, what if I tell you what happened on the second event? Can you figure out which branch we came down to get there? Ooh. We're going to build. Example 1. A pot is randomly selected, and then a bill is randomly chosen from that pot. Okay. What's the probability that, okay, if you know you're in pot 1, what's the probability that you pick a $10 bill? If you know you're in pot 2, does everybody doesn't have the notes? Everybody has the notes? Yes? What's the probability that you get a $10 bill? 2 out of 4. And part 3, we can also handle. What's the probability that the $10 bill is chosen? Well, this is where we would do a tree. We would say, first of all, how many pots are there? 2. So I got pot A, pot B, and there is a 1/2 chance of picking a pot because it says a pot is randomly chosen. And then in pot A, I have 0, 10, or 20, and in pot B, I have 0, 10, or 20. In pot A, it's 1/3, 1/3, 1/3. Double check, they add to 1. In pot B, it's 1 out of 4, right? And then what am I going to put on the 10 here? 2 out of 4. And 1 out of 4. Double check. Those add to 1 as well. By the way, are these 2 branches identical? So these are not independent. A $10 bill is chosen. That's this branch or this branch. Multiply down, add across. The probability of getting a $10 bill is 1/2 times 1/3 or 1/2 times 1/4. Use your calculator. Feel free to use the fraction button on your calculator. What's the answer in lowest terms, please? By the way, it's 1 out of 6 plus 1 out of 8. But the answer is not 1 out of 14. You have to get a common denominator. I can do it in my head probably. It's going to be 4 out of 24 and 7 out of 24. Double check me. Yeah? Sorry, what? Am I wrong, Zach? Did I make a mistake? I might have. 2 out of 4. I wrote it wrong. So it's going to be 2 out of 8, Mr. Dueck, which is going to be... Thank you, Zach. Let's fix that so it's not submissive. Sorry? 5 out of 12. Also, by the way, a fairly counterintuitive answer in that if I'd asked you guys to make a prediction based on that question. Again, we're very good at basic probabilities. We're terrible at anything beyond basic. That's not what that is all review. Here's the interesting question. Suppose you know that your friend played this game and they're holding a $10 bill. What's the probability that it came from pot 1? Can you see what I'm doing here, Jake? I'm telling you the outcome, and I'm saying, can you find the probability that we came down a specific branch? A specific branch. By the way, it's pot 1 and pot 2. I called it A and B. Sorry. I guess I can fix that for you guys. Pot 1, pot 2. We begin by translating this question as a conditional probability. Write that, P brackets, leave a space, and then do our given. What do we know? What have they told us? We know what was chosen. What do they want us to find? No, I got to be careful. They didn't ask us to find which pot. More specific.
Pot one.
They want the probability that we came down pot one given if, suppose that, a $10 bill was chosen. In fact, you can write over here, given that, or if, or suppose. These are all words for that conditional bar. Okay? Someone get out their formula sheet, please. You got it there? Got it? Okay. Can you find for me the equation that says, or is it B given A? How did I write it? I wrote it B given A as a formula. And what did I say that always is?
The probability of
Keep going.
affect B over B.
I don't think it's what I said. Oh, I'm sorry. You're right. I'm sorry. Intersection. I'm not using the notation that I'm familiar with. You're right. It's always going to be write that down. But I'm going to give you a better way to understand. Oh, A on the bottom? Yes, I'm sorry. Good gosh. By the way, because I don't do it this way, I'm going to give you a better way to understand this. Okay, first of all, I have to recognize that it's a conditional probability question. How will I recognize that? I'll notice in my tree they've told me something about the bottom and they're asking me something about the top. Or I see a word sterling like given that, or if, or suppose. And as I have to be able to translate it like this. You good, Jordan? What you looking at? So are you ready? You have to be able to translate the conditional. And as a formula, although it says that, here's what I remember. It's always, write this down please, and over the given one. Write that down. It's always and or both over the given one. Let me show you what I mean. Let's answer the question now, Kyle. It says, if you know that we have a $10 bill, what's the probability that came from pot one? And I'm going to tell you it's going to be the branch that has both divided by the given one. Look at the tree. Which branch has 1 and 10? See it? What are the fractions on there?
1 over 2.
And
1 over
which branches end in 10? 2 of them. See them? The first branch is 1 out of 2, 1 out of 3, or 1 out of 2, 2 out of 4. Right? You guys see, I have to keep this. I can't fit the tree and this on there. But look at the tree, right? Conditional probability, if you want to add it to a tree, start with a formula, but we translate it. We say, look, if you want to go backwards up the tree, if you tell me something at the bottom, it's going to be as a solvable approach. On the top, you put the branch that has both events. On the bottom, you put every branch that has the given event. In fact, you'll notice, Matt, almost every single time, the top two fractions will appear as a group somewhere in the bottom. These don't cancel. You have to do the top. You have to do the bottom. In fact, if we were typing this in now, we would go like this. On the top, bracket. And then we would go 1 fraction 2 and 1 fraction 3. Type this with me. That's how to use your fraction button. Close off the top. Divided by, on the bottom, I would go 1 fraction 2 and 1 fraction 3, or 1 fraction 2 and 2 fraction 4. Close bracket. What'd you get? 2 out of 5. Let's try a couple more. Next page. So, nearly 50 years ago, there was a U.S. mathematician, and he was an expert in using probabilities and conditional probability and sampling methods. And he went to the U.S. car companies. He went to Ford, he went to GM, and he went to, back then, what was called American Motors. And he said, look, I can give you mathematical sampling methods for your factory where you don't have to change a thing, you don't have to change your workers, but you'll catch more defects on the line when they happen. And they weren't interested. The companies weren't interested. So he went to a different country that was just becoming, after World War II, an industrial power, just starting to develop a car industry. Care to guess what country that was? He went to Japan. And he pitched the idea to Toyota and to Honda and what back then was called Datsun, which is now called Nissan. And they totally bought into it. And so the reason why in the 70s and 80s and 90s and early thousands that Japanese cars were better made was because one of the reasons they were much better at catching defects mathematically. So here is some of the basics of what he pitched. Instead of cars, we've got computer chips. Supposing a company has 2 factories that make computer chips. Suppose 70% of the chips come from factory 1, 30% come from factory 2. In factory 1, 25% of the chips are defective. In factory 2, 10% of the chips are defective. Okay? Here is your trigger word in part A. Can you, Matt, read to me the first word of part A? Nice and loud.
Suppose.
That means this is a conditional probability. It says, suppose you don't know. Actually, I stand corrected. I know. Cross that out for a second. Sorry, guys. The conditional is going to be the suppose in part B. I, for some dumb reason, started both of them with suppose, and I'll change that. It says this. Suppose it's not known from which factory a chip came. What's the probability that it's defective? Okay. First, you have to pick a factory. What did I call the factories? What's the probability that you came from factory 1? What percent of the chips are made in factory 1? What? 70. As a decimal? What percent of the are made factory 2.3? Right? Then you can be defective or not. Defective or not. Given that you're in factory, assuming you're in factory 1, what's the probability that you're defective? 0.25, and not defective, 0.75. What about factory 2? What's the probability that you're defective? 0.1 and 0.9. What is part A asking me to find, Matt? What?
What is the probability that chip is defective?
Is it asking me to find something from the bottom row or the top row? Bottom. So this is not a conditional probability. It wants find the probability. Well, you know what? That's going to be this branch. Or what? Right? So how can I find this? Multiply down, add across. Can you tell me what I'm going to write? 0.7 and 0.25, or 0.3 and 0.1. What's the probability that we're defective? Crunch the numbers, please. 0.205, and don't round off, so 0.205. So first of all, you got a 20.5% chance that any one chip is defective. But what the factory would also be interested in is, okay, suppose in their retail store they pick a chip and it's defective. What's the probability that it came from factory 1? Now, a lot of people might say, oh, 70%, Mr. Dueck, because 70% of them are made there. No. So, Jake, what are they asking me to find in part B? What do we know? What's the suppose? What have they told me? Read the question, part B. Read out loud the question, part. Okay, here we go. What do we know? What's the suppose? What have they told me? Read me the whole sentence with an authoritative voice. This is the conditional probability. How do I know? Because they've told me where I am in the bottom row. You're defective. What do they want me to find, Jake? They're telling me where I am here, and they want me to find something. We're going backwards up the tree. First thing we do is we translate this into a probability statement. P bracket vertical line. What's the suppose? What have they told me? What do I know? What do they want me to find? And if I write this, it's going to be both and over the given one, the second one, the given one, the thing that appears after the given. Which branch has both and? Pardon me? Okay, what are the numbers on it? And I like the way you said and, yet multiply. There is the first branch. That's the branch that has both and. Which branches end in D? Which branches have the given one? There's two of them. 0.7, I said the whole branch, 0.25, or 0.3, 0.1. The whole branch, the whole branch, the whole branch. That's the probability, if you found a defective chip, that it came from factory 1. Good, crunch that. Now, you're going to have to put brackets around the bottom on your calculator. You're going to go 0.7 times 0.25 divided by bracket 0.7 times 0.25 or 0.3 times 0.1. And I get an 0.854. Heck, 0.85, yeah, 4 is good enough. There's an 85.4% chance that it came from factor 1, not a 70% chance. We're going to pause here. We'll do some more Friday.